Alright, welcome back. This episode we finally finish our collision detection by filling out the rest of the circle versus polygon corners and adjust a little bit the simulation glass. Good. Here again, I'm gonna say let vertices length is equal to shapes polygon. Shapes. Shape polygon vertices and then length. And then I'm gonna say for I is equal to 0. This is smaller than the vertice's length and I++. We're gonna iterate through every vertex again. Then we're gonna say the current vertex is equal to the shape polygon vertices at position I. Then we're gonna say the direction. We're gonna calculate the direction or n direction vector. That's right. We're gonna calculate an direction vector to the shape circle centroid. Well, basically from the vertex to the shape circle centroid. And yeah, we're gonna use this one then to compare if the vertex is inside the circle. All right, then let's create our direction. So dir to centroid circle is equal to the subtraction with the current vertex to the shape circle centroid. All right, and then we can do our comparison. Here I'm gonna do our optimized comparison I did in the circle versus circle episode. So I'm just saying length 2 here is smaller than shape circle radius times shape circle radius. Okay, and if that's the case, we have a collision. The vertex is inside the circle now. We can calculate our penetration, and this will be the that penetration is equal to shape circle radius. Actually, I'm going to call this one penetration depth, shape circle radius, minus the dir to centroid circle, the length of it. This is the penetration depth. Then we need to normalize this dir to centroid circle to create, well, the penetration normal. So I'm going to normalize that, and then I'm going to return the new collision manifold. And here I'm going to say the penetration depth, the normal. Yeah, this will be dir to center. Yeah, that's the normalized direction vector. So that's the normal, the penetration normal, and then here the penetration point is the current vertex. And if after for loop we still didn't find anything, then we're just gonna return null. All right, and that's it, everything. That's it. Well, wait, that's everything. All right. Yeah, I think, I mean, of course we did some errors somewhere, I guess. But let's check. We need to change the simulation class anyways now. And then we can check if it's working. Here I'm gonna remove, I think I'm gonna remove, no, I'm gonna change this rectangle here to circle. So I'm gonna say new circle. Oh, okay, yeah, that's wrong. New circle. Here that's a new vector. The position, well, actually I can use this one, right? Can I use this one? Yeah, I can use this one. Okay, I'm just gonna copy this one, place it in here. I can remove that. Is that right? Yeah, looks right. Okay, I think I just need to set a other position. I just gonna say 600 and 300 maybe. Yeah, I think I'm gonna say the rectangle will be 600, 400. Well, then the position, I guess, is then wrong, right? Is it no? Well, no, actually not. Okay. Then I'm gonna say here 150 and here also 150. So it's gonna be equal rectangle with equal edges. Okay, I guess I can. Oh no, I still forgot something, alright. Yeah, right. We need to check, well, we need to say, or actually we need to use, well, a second. We need to use check collisions, basically, okay? So I'm just gonna say check collisions here. Then we say object A, object B, that's right, result. Then we're gonna push. Okay, okay. Yeah, that looks good. Okay, let's jump to the browser. Ah. Okay, 1 second though. I didn't open the browser yet. I need to open it now. There we go. Okay, let's jump to the browser then. Okay, as you can see, we did some, or I did some errors. So let's see what these errors are. Reference error, polygon is not defined, collision detection 8. Here, polygon. Oh, okay, I spelled it wrong. Yeah, polygon. I did it everywhere. All right, then just gonna copy this one. Refresh. Ah, right, I forgot that. Okay, here. I changed. I misspelled it. I wrote polygon instead of polygon. Okay, so I'm just gonna copy this and place it like this, and now it should work, hopefully. Or I mean, at least we should see some shapes. All right. Okay, we see some shapes. All right, then let's check if this is working. I can say, oh, okay, the circle versus rectangle collision seems to work. Okay, I'm a bit nervous. Actually, let's see if the corner case is working. Oh no, ah, damn it. Okay, okay, I did some error here. All right, so what's that? Collision detection 171. 171. Let's see. 171. Okay. I need to return a new collision. All right. Yeah. Of course. Okay. Refresh. And let's see the circle again. Oh, I want to see the circle. Okay. Let's see. Oh, that looks pretty good. Okay. Okay. Nice. Okay, so let's see if I can move everything. Just this polygon here. Yeah, this looks good. You can actually see how the rectangle is pushed out. Okay, let's rotate this one. Okay, I'm rotating the circle, that doesn't do much. Okay, yeah, it's working. All right. Cool, very nice. All right, so then we have a collision detection with polygons versus polygons and polygons versus circles. And that's the end of the collision detection, well, let's say chapter. And now at the next, we are going to add a rigid body to our physics engine. Integration schemes and so on. I'm going to show you how we can implement this one. Then there's going to be the bouncing balls example, and then we're going to go to the actually impulses and so on. And yeah. All right, then I wish you a nice day and see you in the next one.